going to go over the CPU in terms of the von Neumann architecture and the registers that the CPU has. I'll put the links to the different parts in the description below so you can skip to the bit that you need. The CPU is responsible for the fetch-execute cycle. Each part of the fetch-execute cycle is carried out by the CPU's registers, the control unit, or the arithmetic logic unit. In 1945, John von Neumann came up with a design that explains how the different parts of the CPU work. His design still applies to modern computers. Each register is super fast memory that stores tiny amounts of information that the CPU can access extremely quickly. The memory data register, or MDR, holds the data or instruction itself. This data might have already been read from the memory, or it might be waiting to be written to the memory. The memory address register, or MAR, holds the memory address that the CPU is about to use. This address can direct the CPU to the data or instructions that it needs. For your exam, there are two other parts of the CPU that you need to know about. The control unit, or CU, is an overall control of the CPU. The CU controls the flow of data within the CPU and is responsible for executing program instructions by following the fetch-execute cycle. The program counter is the part of the control unit which holds the addresses of the instructions for each cycle. The arithmetic logic unit, or ALU, does all of the calculations and performs the logic operations. You'll learn more about what logic operations are when we come to study paper 2. The accumulator is the part of the ALU that stores the result of any calculations that have taken place. All of these sections work together to carry out the fetch-execute cycle. Okay, so you might find all of that easier to remember if we have a look at this animation. So you can see here that the program counter is set to 0. That's because in computer science, computers start counting from 0 rather than 1. Okay, so the program counter is going to pass this value to the MAR, the memory address register. Okay, so that 0 has been passed, and the memory address register knows to go and look this up from the RAM's memory address at 0, and the contents of that are add 1. These contents are passed to the memory data register, and at this stage the program counter can then increment itself up to 1. Okay, ready for the next fetch execute cycle. The MDR will then pass this value into the control unit. And because this is an addition, we're going to need the arithmetic logic unit to get involved. Now, at the minute, there's no maths happening, it's just the value 1, so that can be stored in the accumulator. Once this first fetch, decode and execute has occurred, we can then start again, so the cycle repeats. This time the program counter is set to 1. That value is again passed into the memory address register, and it looks it up from the RAM, and we can see again it's the same instruction, add 1. That's passed to the memory data register, which then passes it to the control unit. Now this time the arithmetic logic unit is going to have to do some maths. It's going to have to take the original 1 value and add 1 to it, and the result of this is stored in the accumulator, so that's updated to 2. What will happen is this will just keep cycling round again and again and again. Okay, so finally, let's have a look at this exam question. Alexandra buys a new computer to enable her to write her university reports using a word processor. The computer uses von Neumann architecture. Tick one box in each row to identify which register the statement best applies to. Now, there are 4 registers listed, but there are 5 statements. So one of these registers is going to have to be ticked twice. Now, the statements are the definitions, so as long as you know what your definitions are, you should be okay. Stores the address of the next instruction to be run, well, that's the program counter. Stores the address where the next item of data will be fetched from, well, that's the memory address register. Stores the result of arithmetic calculations, that's the accumulator. Arithmetic is maths. Is incremented each time an instruction is run, well, that's the program counter again. Stores an item of data that has just been fetched, well, that's the memory data register.